Today we'll talk about matter, the first chapter in your textbook, page number 3. So without wasting time, let us continue with the chapter. And first thing I want to tell you is what matter is. Matter is anything that has mass and occupy space, and it is made up of very tiny particles called atoms. Okay. We all very well know that atom is the smallest particle of an element that can take part in a chemical reaction, and atom does not exist usually doesn't exist independently. Therefore, atoms will combine to form molecules. So we can say that matter is anything that has mass and occupy space. Now we talk about, in page number 3, you can have a look in your textbook, the kinetic molecular theory of matter. The kinetic theory of matter first talks about the composition of matter. As we already discussed just now, that matter is composed of molecules. The molecules of a given substance are identical in all respects. For example, water molecules, water from anywhere. Okay, water, H2O, the molecular formula, dihydrogen monoxide, H2O. Well, it is same everywhere. The molecules of water will not change. For example, sugar. When we talk about sugar, sugar everywhere is sweet to taste, and chemically it is C12H22O11. So the matter is composed of molecules, and molecules of a given substance are identical, same, exactly the same in all respects. That's what it says, the first theory, molecular theory, kinetic molecular theory. Then number 2, movement of molecules and kinetic matter. So molecules in matter constantly move. They are never stationary. The molecules are always in motion. Why? Because it contains kinetic energy. The energy that molecules possess is called kinetic energy, and it is because of the kinetic energy that the molecules are never stationary. They always move around. Intermolecular space. In the solids, the intermolecular space, the space between the molecules, okay, the two molecules, there is a space between them, between the two molecules, and this is known as intermolecular space. So the empty space between the molecules of matter, the empty space between different molecules are called interparticle or intermolecular spaces, and the empty spaces between the molecules get larger as a sample of the matter changes from solid state to the liquid state and gaseous state. That means solids will have very less intermolecular space. Liquids will have a little bit more, and the largest intermolecular space is occupied by the molecules of gases. Intermolecular force of attraction. So there is always a force of attraction between the molecules. Molecules always attract between themselves. The force of attraction between the molecules of the solid is very strong, whereas the gases are very, very less, very, very weak. So solids will have very strong force of attraction, whereas the force of attraction between the molecules of gases is very, very weak. Not only between themselves, they have the force of attraction between other types of molecules, between one type of molecule and the other type of molecules. And it is known as cohesive force and adhesive force. The force of attraction between the molecules of the same kind, let me again tell you, the force of attraction between the molecules of the same kind is called the cohesive force. Okay, like the water molecules and water molecules will have the cohesive force between themselves. Whereas the force of attraction between the molecules of different kind is called adhesive force. Like you put your hand in water, your hands get wet with water. Why? Because there is a force of attraction between the molecules of your hand and the water molecules. Therefore, it gets wet. Okay, so let me give you another example of cohesive force, the force of attraction between the molecules of the same kind. Let me give an example of a new umbrella. So when rain falls on the new umbrella, the cohesive force of what between the water molecules will be more than the adhesive force between the umbrella and the water. So therefore, the water doesn't stick to the umbrella, the new umbrella. Okay. As it gets older, of course, it gets wet. But in the new umbrella, the force of cohesion will be, between the water molecules will be more than the force of addition between the water molecules and the materials of the molecules of the material of the raincoat or maybe the umbrella. So therefore, the water doesn't stick. But if you dip your hand in water, your hands become wet. Why? Because there is a very strong force of addition between the water molecules and your hand molecules. Therefore, the water will stick to your hand and wets your hand. Collision between the molecules. So molecules are always in random motion, especially in the liquids and the gases. So they collide amongst themselves. And they collide against the wall of the container. So if the molecules collide to the walls of the container, then the force is created on the walls of the container. Now, as the temperature increases, naturally the kinetic energy of the molecules will also increase. Therefore, the force, the energy possessed, the kinetic energy possessed by the molecules will be more, and the pressure, obviously, that is why the pressure also increases. Okay? Now, change of state of matter. When we talk about the change of state of matter. Now, what do you mean by the change of state of matter? The melting, there are many processes. Like when we talked about physical and chemical change, I must have told you about the change of state of matter. Solid, liquid, and gases. So this is the, let's say, solid, and we have the liquid and the gases. So there is interchange. The interchange of the state of matter is known as change of state of matter. The solid changing into liquid is called melting, and liquid changing into solid is called solidification or freezing. Solid changing into gas is known as sublimation, and liquid changing into gas is known as evaporation, or we also call it boiling. And so boiling takes place at a fixed temperature, whereas evaporation takes place at any temperature. We call it vaporization. And changing of gas into liquid is known as sublimation. So, solid changing into gas is sublimation, whereas gas changing to liquid is known as condensation. Okay? So this is the liquid changing into solid is known as freezing. And solid changing into liquid is known as melting. Liquid changing into gas is known as evaporation or vaporization, and gas changing into liquid is known as condensation, and solid changing into gas is known as sublimation, or gas changing into solid. So this is called sublimation. So there are different change of state of matter: freezing, melting, evaporation, condensation, and sublimation. So let me talk about now the molecular arrangement in the solid, liquid, and gas. Okay. The molecular arrangement of solid, liquid, and gas. So this is the solid, let's say SOLID, solid. The molecules are very close to each other. The molecules are very, very close to each other. the force of attraction between the molecules is very, very strong. So therefore, the molecules cannot move around freely. It just, even if it gets energy, it just vibrates in its mean position. Okay, and the intermolecular space is very, very less, almost negligible. The force of attraction is very, very strong between the molecules. The intermolecular space is almost negligible, and the molecules are very, very close to each other. And if it gets energy, usually the molecules vibrate in its mean position. So the intermolecular force, I'll read it from the book for you, page number 5. The intermolecular force is the strongest in the, that means the force of, in the solid, that means the force of attraction is very, very strong in the solid. So the intermolecular space between the molecules in solids is practically absent, and the molecules are very closely packed together. That means the molecules are very, very close together. Why? Because the force of attraction between the molecules is very, very strong. So the molecules hardly move around. So they only sort of vibrate in its mean position. In the case of now liquid, in the case of liquids, okay? In the case of liquid, the molecules are further apart as compared to the solids, because the force of attraction is not very strong, it's weak. So the intermolecular force of attraction between the molecules in liquids is quite weak, weaker than that of the solids. So therefore, the molecules are not very close to each other. Okay, since the molecules are not very close to each other, they can they have the definite volume, but they do not have definite shape. Okay, since the force of attraction between the molecules is weak, they do not have a definite shape, and they are not rigid at all. Solids are rigid, they are hard like this. Okay, why? Because the force of attraction between them is very, very strong, and the molecules are very close to each other. So usually all the solids are rigid. Liquids are not rigid. Why? Because the force of attraction between the molecules are weak, and then the force of there's a lot of intermolecular space between them, and they move around. The molecules move around within the liquid. But if it gets energy, obviously the liquid will evaporate and changes into gas. That is something else. But over here, a little bit of heat given, it will move within the liquid. It can move, the molecules can move within the liquid. And the force of attraction is weak. So intermolecular force of attraction is in liquids is not as strong as that in the solids. So the intermolecular space in liquids is more than the solids, and the molecules are less closely packed. The molecules are not very close to each other. The molecules in the liquid can move from one position to another within the liquid. That is why liquid have the property of being able to flow. That is why they can flow from higher level to lower level. Molecules in liquids collide more frequently with each other than the gases do in a shorter distance between them. So the molecules also collide between them. They bang between them. They collide to the walls of the container to give you exerts pressure to the walls of the container. Now, in the third state of matter, there are three states of matter, as we already know: the solid, the liquid, now the gas. In the gases, the molecules are very, very far apart, extremely far apart. Okay? Why? Because the force of attraction is almost negligible in the gases. That is why, since the force of attraction in the molecules of the gases is extremely weak, they flow in all directions. They can flow wherever it wants to. It does not have a definite shape. It does not have a definite volume. So the intermolecular force of attraction is the weakest in the gases, almost negligible. So the intermolecular space in gases is the largest in comparison to liquids and solids. As a result, The molecules in gases are very far apart. Since the force of attraction is very weak, the intermolecular distance is also, space is also very, very large, and they randomly move. Since the force of attraction between them is very weak, they randomly move in any direction and fills the space. That's why they do not have definite shape, and they do not have definite volume. So the molecules in gases also frequently collide with each other and with the sides of the container in which they are kept. So like the liquids, the gases also collide with the molecules of the gases also collides with the wall of the container and exerts pressure on the walls. Now, since we dealt with the properties of the or the arrangement of solid, liquid and gas, now we will talk about the change of state. Why does a change of state occur? When a solid is heated, obviously the molecules will gain kinetic energy and they become very, very active. And in the solids, they vibrate in the mean position. They vibrate in the mean position. The molecules try to overcome the intermolecular force of attraction. So they vibrate faster and start to move, and the intermolecular space between them slowly increases. Now, what happens is when the solid is heated, okay? When the solid is heated, the molecules are very close to each other, extremely close to each other when you are heating the solid. When you are heating the solid, the molecules, since they are very close to each other, they do not move around much. But after receiving the energy, the heat energy, the kinetic energy increases. So kinetic energy means energy due to motion. Potential energy means the energy due to its position. Okay. Potential energy is the energy acquired by a body due to its position. But kinetic energy is the type of energy any substance will possess due to its motion. So kinetic energy, now it receives the kinetic energy of the molecules will increase and they vibrate more within the mean position. So as the kinetic energy increases, it surpasses the intermolecular force. There is an intermolecular force of attraction is very, very strong. But if you heat enough, what will happen? The kinetic energy will be more than the intermolecular force of attraction. The kinetic energy possessed by the molecules now becomes more than the intermolecular force of attraction. So therefore, they tend to go further away from each other. They tend to go away. That means the intermolecular force increases because the kinetic energy increases. The kinetic energy possessed by the molecules becomes more than the force of attraction of the molecules. So therefore, they tend to go away from each other. They tend to go away from each other and attains the molecular arrangement of the liquids. Therefore, the solid will turn into liquid. Is it clear? Once more, I'm going to tell you. When you heat the solid, what happens is the molecules absorb the heat energy, and the force of and the kinetic energy of the molecules increases. The kinetic energy of the molecules will increase. So as kinetic energy becomes more than the intermolecular force of attraction, they tend to go further away from each other. They just don't vibrate in its mean position. They tend to go away from each other till they attain the arrangement of the molecules of a liquid state. So therefore, the solid changes into liquid state. Similarly, when you heat the liquid now, what happens is the molecule, there is a force of attraction. The intermolecular force of attraction in the liquid is not very strong, but it is there. There is a force of attraction between the molecules of the liquid. Now what happens is when you heat the liquid, again the kinetic energy of the liquid molecules, the molecules of the liquid will increase. It becomes more than the force of attraction between them. So therefore, they move further away from each other. Since the kinetic energy of the molecules increase, they tend to move away from each other. They tend to move away from each other and attain the intermolecular arrangement of gases. The molecular arrangement of gases. That's why when you heat the liquid, it will evaporate, it will change into gas. Is it okay? So that's it. How the the change of state of matter occurs. And similarly, reverse thing happens. The reverse thing happens when you cool the gas, like water vapor. When you cool it, when you cool the water vapor, it changes into water. It changes into liquid. The gas changes into liquid, isn't it? Why? Because when you cool, what happens is the kinetic energy of molecules of the gaseous state in the gaseous state becomes lesser. So, and the intermolecular force becomes a little bit more, stronger and stronger. So, because the kinetic energy decreases now, intermolecular force of attraction will become more. So, what happens is they come back to its liquid state, having a little bit stronger intermolecular force of attraction and lesser kinetic energy. Similarly, when you cool water or when you cool the liquid, it changes into solid. It solidifies. Why? Because heat is taken away and it loses heat. The molecules will lose heat, means it loses kinetic energy. So therefore, the intermolecular force of attraction becomes stronger. So the molecules will become closer to each other and attain the molecular arrangement of the solid. So the reverse thing happens when you cool it. When you heat it, solid changes into liquid, liquid changes into gas. But if you cool it, gases changes into liquid and liquid turns into solid. That means it freezes. Is it okay? Now, law of conservation of mass. So, law of conservation of mass says, I read it from the book, page number 7. The molecules in a substance remain the same when the substance changes its state. Like, for example, solid changes into liquid now. The solid changes into liquid now. The number of molecules will remain the same. It will not change. The things that change are intermolecular space between the molecules and the arrangement and the movement of molecules. So what changes? The total number of the molecules in the solid as it changes into liquid. In liquid also, it has, suppose a solid has 100 molecules, the liquid will also have 100 molecules, but what will be different? The intermolecular space becomes a little bit more as compared to the solid. This means that the mass of a substance remains the same. So since the number of molecules remains the same, despite the intermolecular space and the change in the intermolecular force of attraction, the number of molecules remain the same. So therefore, the mass also remains the same if there is any kind of interchange of state of matter. For example, 10 grams of water boils to form 10 grams of steam, or freezes to form 10 grams of ice. So 10 grams of water, if you heat it, it becomes 10 grams of steam. 10 grams of water, if you cool it, it becomes 10 grams of ice. The mass will not change. So this is called the conservation of mass. So the law of conservation of mass was put forward by Antoine Lavoisier. It states that matter is neither created nor is it destroyed. So this means that there is no change in the mass during a chemical reaction. So there is no change in the mass if there is a chemical reaction. In other words, the mass of the product is equal to the mass of the chemical. So for example, reactant. So let's say carbon plus oxygen produces carbon dioxide. So there is no change in the mass of the substance, like hydrogen plus oxygen will form water. So when we balance it, okay, we balance it here. Oh, this is already balanced. So water, hydrogen, two molecules of hydrogen reacts with one molecule of water to form two molecules, one molecule of oxygen to form two molecules of water. So there is no change in the mass in the chemical reaction. So in a chemical reaction, a change in the composition of substance occurs, but there is no overall change in the mass. For example, as magnesium burns in oxygen to produce magnesium oxide, the total mass of oxygen and magnesium reacted equals to the mass of the magnesium oxide produced. Okay? So, magnesium burns very, very brightly in oxygen to produce magnesium oxide. If we balance it, 2 Mg plus O2 produces 2 MgO. So ash sort of a substance, magnesium oxide, is formed when magnesium burns in oxygen. So if we calculate the mass of magnesium used and the oxygen used, that will be equal. This is the reactants. This is the reactant and this is the product. The reactants of the mass of the reactants. The mass of the reactants we see will always be equal in a chemical reaction, will always be equal to the mass of the product. That is what we call the law of conservation of mass. So, with this we come to the end of the chapter. So, today we talked about matter, the definition of matter, the kinetic molecular theory of matter. Number one, it says it deals with the composition of matter. It is made out of molecules, movement of molecules and the kinetic energy. So in solids, the molecules just vibrate in its mean position. It doesn't move around. But in water, the molecules move around within the liquid, whereas in gases, the molecules, since the force of attraction is very weak, it can move around anywhere it likes. Therefore, it does not have a definite volume. The intermolecular space, now it depends. The solids will have very less intermolecular space. Why? Because the force of attraction is very strong. In liquids, the force of attraction is weak, so therefore the intermolecular space is larger. Whereas in the gases, the intermolecular force of attraction is almost negligible, so therefore it has very, very large intermolecular space. So we talked about the cohesive force and the adhesive force. So cohesive force is the force of attraction between the same type of molecules, and adhesive force is the force which exists between the different types of molecules. And the force of collision of the molecules and the movement of molecules in different states. Like molecules do not move easily in the solid, whereas in liquid, water moves, the molecules move within the volume of the liquid, whereas gases, they move everywhere. Now, change of state of matter, we talked about that. What happens when we heat the solid, liquid and the gas? When we heat the solid, it gets enough kinetic energy, and the intermolecular space increases. Why? Because the kinetic energy is more, so the kinetic energy becomes more than the force of attraction between the molecules, so they start separating from each other, and it attains the intermolecular arrangement, the molecular arrangement of the liquid. Similarly, if you heat the liquid, the kinetic energy of the molecules of the liquid becomes more than the force of attraction between the molecules, so it attains the molecular arrangement of the gases. The reverse thing happens when you cool the gases. The kinetic energy is lost, it becomes lesser, and the force of attraction becomes more, and it comes closer till it attains the arrangement of the liquid. And then when you cool the liquid, what happens is the kinetic energy, when you cool the liquid, the kinetic energy of the molecules will decrease. It loses the kinetic energy, and the intermolecular force of attraction becomes more, so therefore it comes closer to each other and attains the arrangement, the molecular arrangement of the solid. So as we also discussed about gaining energy and how the interchange of state of matter takes place, and ultimately we talked about the law of conservation of mass. So law of conservation of mass tells you that the mass of whatever the reactants used will always be equal to its product. Okay, so in the next offline class, WhatsApp class, I will be giving you a little bit of important notes on this chapter. Okay. Thank you so much.